So this time we're going to have a look at the distance between two coordinate points. So again, I've got my coordinate points, and this time I want to find the length of the line between the two, or the distance between the two. And to do that, I can use the two distances in x and y to form a right-angled triangle, which means that I can use Pythagoras. So the equation for this is listed here, but instead of learning that whole equation, we can just think about Pythagoras to help us. So the first coordinate here is 3, 5, and the second coordinate is 10, 10. And we're going to use Pythagoras to help us to find the length of the line. So the difference in x, I need to try and find how far I've gone across, is 10 minus 3, and that's 7. So that means that if I redraw my triangle here, the distance across is 7. And then if I think about the distance in the y, I've gone from 10, or from 5 to 10, so 10 minus 5, and that gives me 5. So I now know the two measurements for each side of my triangle, and now I can use Pythagoras. So I square the two smaller sides, and that gives me the longer side squared. So let's call this L. And then again, I can type that into NSolve and find my answer, or you can do it by hand by simply typing in 7 squared plus 5 squared, or 49 plus 25. That gives me 74. And then I need to square root my answer to give me the length of the side, and the square root of 74 gives me 8.60, and then that would be the length of the line. So there's two different questions here. The first one, we're finding the length of the line between -2, 1 and 3, 3. So if I just draw that out, I've got -2, 1, and I've got 3, 3, and I have the length of the line between the two. So if I think about the difference in the x, then that would be from 3 to -2. So I need to subtract them. So this time I've got a negative number. So I've actually travelled 5 between the two. So think about the number line going from -2 to 3. And then I'm going to do the same on the y. So I'm going to subtract the 2. So 3 minus 1, and that gives me 2. So I've gone up by 2 and across by 5. And now I can use that to do Pythagoras. So I square the two smaller sides, and that gives me the length of the longer side. And then again, you can either use Pythagoras and do it by hand. So 25 plus 4 is equal to 29. And then you need to find the square root of that answer. So the square root of 29, which is going to give you 5.385. Or you can type that straight into your GDC and use NSolve from this point, and that would give you the same answer. The second question, again, is a little bit more wordy to think about. So on the second one, we've got 3 different points. So if we think about the coordinate axis, we've got the first one, which is -2, 0. So that's somewhere here. We've got the second one, which is 2, 1. And we've got the third one, which is 1 minus 3. So these are my 3 coordinates. 2, 1, minus 2, 0. And it says that they form a triangle. So I've got a triangle here if I draw between them. And I need to work out if it's equilateral, isosceles, or scalene. So an equilateral triangle is where all 3 sides are the same length. An isosceles triangle is where two of the lengths are the same, but the third one is different. And a scalene triangle is where all of the lengths are a different size. So I'm going to have to find the length of all 3 lines to find out which of these it is. So if I take the first one, I'm going to use minus 2, 0, and then 2, 1. So I'm just going to draw that out. So I've got minus 2, 0, and 2, 1. Let's do that line first, and we're going to try and find out how far we've gone across in the x, which is 4, and how far we've gone up on the side, which is 1. So 4 squared plus 1 squared is equal to the length of the line squared. So if we just use L for length of the line, and then we've got 4 squared is 16, plus 1 squared is 1, so that gives me 17, and I want to then find the square root of that answer. So I've got the square root of 17, which gives me 4.123. Then I'm going to take a different side. So this time I'm going to take this one here. Let's keep them the same colour. And this one goes from 2, 1 down to 1 minus 3. And again, I'm going to try and find the length of each side. So if we think about the x coordinate, I go from 1 to 2, so it's a length of 1. And I go from minus 3 to 1, so that's a length of 4. So I've got 4 squared plus 1 squared equals L squared. So it's actually exactly the same as the one I've just done, 4.123. So it can't be a scalene, because that would be all of them different. So it's either an isosceles or an equilateral. I just need to check how long that third line is. So the third line is going from minus 2, 0, down to 1 minus 3. And again, I'm just going to find the length. So between the x, I've moved minus 1 or 1. It doesn't really matter. I don't need the negative because it's just the length of 1. And between the y, I've gone a distance of 3. So again, you don't need any negatives in Pythagoras. It's just the length. So now I can find the length of that line. So I have 1 squared plus 3 squared equals the length of the line squared. So that gives me 1 plus 9. And then I need to square root that answer. So it's a square root of 10. And that gives me 3.16 or 3.162. So we can see that 2 of the lines are the same length and 1 is different, and therefore it is an isosceles triangle.